Hello dear students. So now we will move on to theorem 3.3. The statement is A. If D is not congruent to 1 mod 4, then Q of root D has an integral basis of the form 1 comma root D and discriminant 4D. If D is congruent to 1 mod 4, then Q of root D has an integral basis of the form 1 comma half plus half root D and discriminant D. So in the last class, we have studied theorem 3.2, which gives a description about the the integers of Q of root D in two cases, when D is congruent to 1 mod 4 and D is not congruent to 1 mod 4. So first we will prove A. So we have that D is a square-free rational integer. So this we have to write, if D is a square-free rational integer such that, and so first we will assume the first case, that is D is not congruent to 1 mod 4. So if D is not congruent to 1 mod 4, then by previous theorem, then by theorem 3.2 we have, so in the theorem 3.2 we have studied that, we have proved that ring of integers of Q of root D is Z of root D. Q of root D is Z of root D. Okay. So we know that that 1 root D forms a Z basis. So this implies that since it forms a Z basis, we got that 1 root D is an integral basis for Q of root D. So we got an integral basis for Q of root D. Now next we have to show that the discriminant is 4D. Now how do we calculate discriminant? Using the formula, we have discriminant of 1 comma root D equal to, it is determinant sigma I of alpha j whole square. Okay, so here you know quadratic field, so it is of degree 2. So we have 1 root D 1 minus root D, whole square. So if you simplify this, you will get minus root D whole square. So minus 2 root D whole square. So it is nothing but 4D. So in the first case, we have shown that if D is not congruent to 1 mod 4, then the set 1 root D is an integral basis for Q of root D, and the discriminant of this set of this integral basis is 4D. So this result is very important. You have to remember the statement of theorem 3.2 as well as theorem 3.3. Now we will see the B part. So in the B part, we will assume that D is congruent to 1 mod 4. So D congruent to 1 mod 4. Then by the previous theorem, we know that the ring of integers of Q of root D. By theorem 3.2, we will get this as Z of half plus half root D. That is 1 plus root D by 2. So this is the ring of integers. Ring of integers of Q of root D is Z of half plus half root D. Then we know that since this is Z of half plus half root D, then the set 1 comma half plus half root d, that is 1 plus root d by 2, form an, this form a z basis. So this will form an integral basis for, integral basis for z of half plus half root d. So this form an integral basis for q of root d. Okay. The ring of integers for q of root d. Okay. This is the this form a set to 1 comma 1 plus root d by 2 form a z basis for this ring of integers. Okay, so z basis for ring of integers is called an integral basis for k number field. So here k is q of root d. So this form an integral basis for q of root d. Now next we have to find its discriminant. So as we did in the A part, now we will see what will be the discriminant of 1 comma 1 plus root d by 2. Since quadratic fields have degree 2, so you will get a 2 by 2 metric. Discriminant is determinant sigma I of alpha j whole square, where sigma I are the monomorphism. So here we will get exactly 2 monomorphism, and this here will get 1 plus root d by 2 and 1 minus root d by 2 whole square. Okay. Now we have to simplify this. So it will be 1 minus root d by 2 minus 1 plus root d by 2. So you can see that half will get cancelled. So you will get minus 2 root d by 2. Root d by 2 will get added whole square. So this is nothing but d. Okay. So the discriminant is d if d is congruent to 1 mod 4. The discriminant happens to be d itself. So the statement of the theorem is also very important. You have to remember it. We will do one problem so it will be more clear to you. Find, so this is very important section. Find the integral basis and discriminant of, find the integral basis and discriminant of q of root 3. Also q of root of minus 7. 2 problems, we can do it here. So first we will see q of root 3. Okay. So we know that 3 is square free, and we have 3 is a square free number, square free, and also 3 is not congruent to 1 mod 4. Okay, that is 3 minus 1 is 2, is not a multiple of 4. Okay, so 3 is not congruent to 1 mod 4. So it comes under case A of the previous theorem. In previous theorem we had case A and case B. So it comes under A part when 3 is not B is not congruent to 1 mod 4. Okay, so in this case the integral basis is integral basis. So by theorem 3.3 it is 1 comma root d. So here it is 1 comma root 3. So this is the integral basis. And what is the discriminant? discriminant of 1 root 3 by theorem it is 4d. Okay, so it is 4 into, here d is 3, so 4 into 3, so it is 12. So we got the integral basis and the discriminant. So the only thing is that you have to remember the formula, the statement, and you can do the problems very easily. Now next we will see for q of root of minus 7. Q of root of minus 7. So you have to see whether it is congruent to 1 mod 4 or not. So we see that minus 7 is congruent to 1 mod 4. Okay, because minus 7, minus 1, minus 8 is a multiple of 4. Okay, so minus 7 is congruent to 1 mod 4. So it comes under case B of theorem 3.3. Okay, so from there we will get that the integral basis is of the form 1 plus 1 root 3 by 2. So we have the integral basis is 1 plus half root d by 2. So 1 comma half 1 plus root d. So it is 1. You will get 1 plus root of minus 7 by 2. This is the integral basis. And discriminant of 1 comma 1 plus root of, either you can do discriminant and find here, or if you remember the theorem you can directly write it is d. So here d is minus 7. Okay, or if it is a problem in the part A of the question paper, so you can find discriminant by doing the problem by finding determinant, and as we did in the previous theorem. If you are using the theorem directly, you have to write the statement of the theorem in the problem. Okay, so this section is very important. Theorem 3.1, 3.2, 3.3. Okay, you have to remember the statement and the formulas you have to remember. You can see that if you remember the results, you can do the problems very easily. And this part is also an important one. Okay, thank you.